Hi, everybody. This is problem number 6 from the worksheet. The problem says something like you have a rack or some sort of a device that's designed to test electronic equipment and how sturdy it is and how well it can handle accelerations. You have something that's in a car or an airplane or some other device that's going to be accelerating. You want to make sure it can withstand those accelerations. So, what we know about the device is it's set up so that there's an amplitude of 20 millimeters. Now, this is not a lot. This is less than an inch, right? 25.4 millimeters is an inch. So this is a very small amplitude. But it's set up so that it can give the object 10 Gs of acceleration, 10 times the acceleration of gravity, or in other words, 98 meters per second squared of acceleration. So that's a pretty healthy acceleration. And the question is, what is the frequency of that device? How frequently does it have to bounce or wiggle back and forth in order in that amplitude to provide that much acceleration? So we've got to take a look at this. We've got to think about this. What relationship or equation do we have that relates these three variables? And I think the one we want to talk about is one we've used on an earlier problem that I did. And it looks something like this. The maximum acceleration is equal to 4 pi squared f squared a. All right, 4 pi squared f squared a. And then simply what we want to do here is we want to solve for f. So it's going to look something like this, I think. I'm going to divide by 4 pi squared a. All right, so that cancels and that cancels. And then I'm going to take the square root of both sides. So I've got the square root of a max over 4 pi squared a. Now the thing I've got to remember is that 20 millimeters is 0.02 meters. You've got to have your amplitude in meters in order for this equation to work out. So I'm going to plug in what I know. Clear. 98 divided by 4 divided by 3.14 squared. Whoops. Okay, start over again. 98 divided by 4 divided by 3.14 squared divided by the amplitude, which is 0.02. And then I've got to take the square root of all that. And I get 11.15 or so. And of course, the unit for frequency is hertz. So there's my answer.